Okay, so here we've got two spheres colliding, and we're told the velocity of approach 3, 2 and 4, minus 1. So immediately we need a diagram, and we need to mark on what happens afterwards. So afterwards this will bounce off like that, and that will stay as 1. So we've got B this way. We don't know what B is, but we know it's going to be 1 in that direction. Don't need the minus because I've got a direction on there. So I know it's going to go this way, and going upwards. That carries on unchanged, so I know that will be 2 because contact is in this direction, but I don't know this component here, so I'll call that A. So it's heading off in that direction. Okay, so that's my diagram. I'm going to do conservation of linear momentum. I'm going to do it horizontally, in effect, because the vertical components don't change, 2, 2, 1, 1. So there's no point in doing it that way. I'm actually just doing it in that direction. Okay, so I get 3 times 0.2. Take away 4 times 0.4. 4 times 0.4 equals B times 0.4. Take away 0.2 times A. Okay, so that gives me minus 1 is 0.4B. Take away 0.2A. Times it by 5 just for convenience. Okay, equation 1. We're then going to look at the impact. Again, we're looking in this. We've got speed of separation. So we've got B and A in opposite directions. So it's A plus B, or B plus A, equals speed of approach, which is 4 plus 3, so it's 7, times E, coefficient of restitution. So we've got two equations, 1 and 2. I'm going to solve those simultaneously. I'm interested in one particular, velocity of A. So it's A I'm trying to find. So I'm going to, okay, so I've got minus 5 equals 2B minus A. I know that 14E equals 2B plus 2A. If I take them away, I get minus 5 minus 14E equals minus 3A. So I multiply all by minus 1 and divide by 3. I get A equals 14E plus 5 over 3. I'm told in the question, which I probably could use earlier, that E is 3/7. I just spotted it. So E equals 3/7 tells me that A 3/7 times 6 plus 5, 11 over 3. Okay, I could have plugged that in earlier to be honest, but anyway. So we've got 11 over 3. So we've got V. Call this one V. So V equals minus 11 over 3I plus 2J. Okay, that's the velocity of A. So that would be better notation. Velocity of A. Find the magnitude of the impulse received. So impulse is change in momentum. Mass It's either impulse received or impulse given, depends on how we're phrasing this, but so that comes out to be 0.2 times minus 20, so it's minus 4 over 3I. So the magnitude of the impulse equals 4 over 3. Okay, that's the impulse received by A. Now we've got the next bit. Calculate to the nearest degree the angle of deflection. Okay, so for the angle of deflection, it's heading off in the direction 3, 2 initially. We know afterwards it heads off in the direction minus 11 over 3, 2. And we want the angle of deflection here. So the simplest way, we could use angles, but the simplest way is a dot product or scalar product. So we're going to do minus 11 over 3, 2, dotted with 3, 2. Notice they're both going away from the angle, so we'll get the correct angle. Equals root 13, magnitude of this one. Root 17 and 4/9, I believe it is. But clearly we do this on a calculator. Cos theta. And we get cos theta times that times that divided by these two. So this is minus 7, just to make sure we're doing it right, over root 13, root 17 and 4/9. So we get cos theta equals minus 0.465 to 3 figures. So theta comes out to be 117.7 degrees. Perhaps a bit too accurate. Theta is 118 degrees. The 3 significant figures.